All right, let's dive right in. Today, we're tackling one of the most maddening things about AI assistants, why they can give us such messy, fragmented answers. And more importantly, we're going to look at a powerful new technique designed to fix it. You know the feeling, right? You ask a really complex, nuanced question, and the AI comes back with this collage of disconnected text snippets. It's like it found all the right puzzle pieces but has absolutely no clue how they fit together. So what is going on here?
And this quote right here, it just hits the nail on the head. We tend to blame the AI for hallucinating, but that's not really the issue. The real problem is how we're asking it to find information in the first place. The system itself, the retrieval architecture, is broken.
So to really get why the solution works, we first have to understand the problem. And that means taking a hard look at the current industry standard, which is called Retrieval Augmented Generation, or RAG. It's the engine behind most of the question-answering AI you use today.
Here's where things start to go wrong with standard RAG. Imagine it takes your perfectly organized documents and just chops them up into a bunch of isolated, uniform chunks. This is called hard chunking, and it completely destroys the original context. Then, the AI searches this pile of text fragments for things that are semantically similar. It's kind of like vibe retrieval. But here's the thing. Similar doesn't always mean relevant. This whole process completely flattens your data structure, making any kind of complex step-by-step reasoning almost impossible.
This analogy is just perfect. Think about it. Giving an AI a dozen random text chunks is like asking someone to summarize a classic novel by just handing them 12 pages ripped out of the book. Of course they're going to get it wrong. The context is gone, the story is lost. All you have are fragments, not real understanding. And that brings us to the absolute heart of the matter. The biggest failure of chunking is that it throws away the most valuable part of your data, the relationships between all those different pieces of information. So the big question is, how do we keep those relationships intact? Well, the answer is to stop thinking about our data as a library of separate files and start seeing it as a knowledge graph. Now, don't let the name intimidate you. It's really just a map of your information, where important things, or entities, are connected by the relationships between them. Just think about that difference for a second. A bag of text chunks is just a jumbled mess. But a map? A map actually shows you how to get from point A to point B. It preserves all the connections, the structure, the logic that standard RAG just tosses in the trash. So how does this actually work? It's surprisingly simple. First, you identify the key things. These are your nodes. They can be people, places, concepts, you name it. Then you define how they're connected. These are your edges. So, for example, the node Albert Einstein is connected to the node theory of relativity by the edge developed. That's it. You've just created a simple machine-readable fact that captures real-world knowledge. And this is where our hero finally comes on stage, GrapgRAG. It's a technique that uses this powerful, structured knowledge graph as the foundation for AI retrieval, and believe me, it completely changes the game. Okay, let's put these two head-to-head. You can really see the difference here. Traditional RAG sees the world as a pile of isolated text chunks. GrapgRAG sees it as an interconnected network. This is a huge deal because it means that precious structure is preserved, not lost. And crucially, reasoning becomes native to the system. The AI can literally follow the connections, making it perfect for those big, complex, thematic questions. This shift completely redefines the act of retrieval. We're not just searching for words that sound similar anymore. Now we are traversing a web of actual logical connections. So, how do we build this amazing graph? Well, it's all done up front, during the indexing phase. First, an LLM scans all the documents to pull out the key entities and their relationships. Then it builds the graph, intelligently merging any duplicates it finds. After that, it finds related clusters of information. These are called communities. And finally, it generates summaries for each of those communities. All of this heavy lifting is done before a user ever even asks a question. This right here is the fundamental shift. Let this sink in. Vector search gives you what sounds like your query. Graph traversal, on the other hand, gives you what is logically connected to your query. One is basically a game of hot or cold, while the other is a journey of pure reasoning. And the payoff for all this upfront work? It's enormous. It allows our AIs to answer entirely new types of questions, questions that were basically impossible to answer before. Look at what this enables. With GrapgRAG, you can do what's called multi-hop reasoning, connecting an idea in one document to another in a completely different document. You can find overarching themes across thousands of files, navigate complex hierarchies, even compare different sets of data. And of course, it can easily tell the difference between Apple the company and Apple the fruit because their network of relationships looks completely different. Let's make this super concrete. A normal vector search would totally bomb this question. It might find some documents about Alice and maybe an org chart with Bob in it, but it has no way to connect the dots, to follow that chain from Alice to her projects to her collaborators, and then check if those collaborators report to Bob. GrapgRAG just follows the path. Simple as that.
Here's another incredibly powerful example. This question demands a comparison between two different sets of relationships, the skills that projects require and the skills that team members actually have. A standard RAG just can't do that. But a GrapgRAG, it can map out both sets of connections and instantly show you where the gaps are.
Now, this doesn't mean you should run out and throw away your vector search tomorrow. GrapgRAG is incredibly powerful, for sure, but it's not a silver bullet. It really comes down to choosing the right tool for the right job. You have to be realistic about the trade-offs. That whole indexing process, it's expensive. It can burn through a ton of LLM tokens just to extract all the entities. And the quality of that extraction isn't always perfect. It can be noisy. Plus, managing and querying these massive graphs can get really complex as they scale. So here's the practical takeaway. You should probably stick with traditional RAG for your simple, factual lookups, especially when speed and cost are your top priorities. But when you're dealing with complex, exploratory questions, and when the relationships within your data are the most valuable thing you have, that's the time to bring in GrapgRAG. Ultimately, picking the right approach boils down to this one simple question. How do you see your data? Is it just a pile of disconnected files? Or is it a rich, interconnected network of knowledge that's just waiting to be explored? Your answer to that question will decide whether your AI is just finding text or if it's truly starting to understand.